Howdy, periodic trends. Here we go. All right. So I've got pulled up a periodic table over here. This is the modern IUPAC, International Union of Pure and Applied Chemistry. This is the modern, up-to-date periodic table. Some interesting things about it, and then some little details we're not wild about. So we've got our standard stuff over here. You notice we don't really have the staircase labeled, so you want to know where that staircase is. And we're not quite sure what happens down here. All right. So then you'll notice some kind of wonkiness going on with the lanthanines. They've just got them labeled lanthanines. And instead of there being 10 across here and 14 in the Fs, what we actually have going on is 15 down here, because there's been some debate on whether lanthanum needs to be here or we need to put lanthanum down here and Lu up here. That would make the electron configurations a little bit easier. There's no doing the 6s2, 4f14, 5d10 kind of combination. Now you would just roll automatically and not have to remember to come back and pick up lanthanum. But they've got a committee on it. They've written a bunch of books, a bunch of papers, 3 or 4 books, I guess, maybe more. Mostly telling us how hard the problem is. So when they, run out of book ideas, I guess we'll have us a better idea of what's going on with it. Okay. So, whatever. We got all kinds of stuff in view in different places. All right, so we're going to be looking at the periodic table. But instead of looking at this one, let's look at the one that's in our book. So this is the one I usually give on tests. I can tell it's quite old. It's not filled in. The original picture was a color picture. Let's see. I apologize. Periodic table. Oh, here's a pretty one. Hey, it's filled in. Look at this nice big book. Let's show you this pretty one. So it's got all kinds of colors and everything else going on. Big bold. You notice they haven't decided what to do down here with our staircase. And they said metals are that way and non-metals are this way. No mention of metalloids or semi-metals. They got lanthanum still over here. Okay. So still some debate on this. This is what? Zumdahl. So this is the Gen Chem 1 book, Gen Chem 2 book currently. So yeah, okay. They also have 8A, and they've got all this. Oh man, no Roman numerals. That's kind of okay. So let me go back. Let's look at this one. So we're going left to right here. First, let's start with the name, periodic table. All right, so let's go ahead and pop over here to this PowerPoint. So the physical and chemical properties are periodic functions of their atomic numbers. In other words, if I take 1 through, let's skip 1 and 2. Let's do 3 through 10. So we'll do lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. And if you put a sample of each of those next to each other, and then you do a sample of sodium and magnesium, you start to see these patterns that kind of repeat. They're not perfect, but they're repeating patterns. And a lot of people equate this to the notes in music. And so looking at this, we've got a period is the horizontal row. You want to be careful. So when we look at this kind of thing, the word period goes up and down, but it's talking left and right. And so you can just name the period by first period, second period, third period, and so on. Easy enough. Don't forget the lanthanides and actinides here are actually on period 6 and period 7. This one's nice and got it labeled down here for us. So that makes life a little bit easier. And they've pulled them out specifically so that we could do our electron configurations. And so let's pop us back over to this one. Okay, so groups or families. I like the term family. Group is nice and short, but family describes better what's going on. a family, they share very similar chemical properties, and they slowly change as you move down the group. Okay, very similar chemical properties inside a family. All right, so several different ways of naming these. So let's look over here at my periodic table. This one's a good classical kind of American periodic table. So we've got a couple of different names. All right. First, you can see these 1A, 2A. These things have Roman numerals. So we better review our. So if this is 1, that's 1A. And so this would be 4A and 7A and so on. Right. And there would be 9. So make sure you remember your Roman numerals. And we notice this A and B. And so when I look at my periodic table, I see this labeled representative elements and transition elements. And so that's our first kind of dividing lines. Now, what I usually refer to these then, this A and B. So B is transition elements. If I can spell it, transition elements or transition metals. All right, and a lot of them will be called because they all happen to be metals. Now, the ones that have an A in the American periodic table after that Roman numeral are representative elements. All right. You'll also hear us old people refer to those as main group elements. That's not a completely acceptable term anymore, just because the people that work in the transition elements, hey, there's more of them. Why are those the main group? The reason why is because some of our trends hold more true, and the patterns are easier for the representative elements. So if I got rid of this label up here that said representative elements, then we would be able to tell these A's over here. But you notice we also have just the 1, 2, 3. And when I went back and looked at the current IUPAC, or even that this other one, they get rid of the A's. And that has to do with this wonkiness going on here. So here's 1A, 2A, 3A is over here. And down here is 3B, 4B, 5B, 6B, 7B. 8B's got 3. What? And then 1B is just, what? So, international system then, we'll go into reasons later. It had to do with differences in the Russian and the American periodic table. But so here's the 1, 2, 3, 4, and then you just go 1 through 18. So which ones are the main group elements or the representative elements? That's groups 1, 2, and 13 through 18 if we're just going with that new system. And then the transition here then would be 3 through 12, including the inner transition elements, the lanthanides and the actinides. But those of us that have been doing electron configurations, then is an even easier way of saying this. The representative elements are the S and the P blocks. And the transition elements are the D and the F blocks. And that actually kind of make things a little easier in my head, since I already kind of remembered where the S's and the P's were. This makes life a little bit easier. So splitting those up, those aren't the groups. That's just some information given by the group name. So what are we talking about for the group names? Well, we've got stuff like 4A. 4A. All right. That same group, 4A, happens to also be 14. So we can call it group 14, group 4A. And then the head of that group and that family, when I come over here, here's 4A or 14, and the head of that family is carbon. And so this is the carbon family. Okay, so 3 acceptable names for every group: representative, transition. Those are not acceptable names. Those are just categories. The names 14 4A. So it's either the A or the B with the Roman numerals, or it's going to be the group, or it's going to be the head of the family. But there are 4 of these that we also need to memorize. And so those 4 are listed up here, where we have a list of the alkali metals. That's 1A, that's group 1. All right, and the alkaline earth metals. How do I remember that? Well, okay, so 2 is bigger than 1, and so group 2 gets a longer name. So the alkali metals over here on the left, alkali metals, alkaline earth metals. On the far side, we've got the halogens in group 17. And then the last one over here in group 18 is the noble gases. Now, it had an older name of inert gases, meaning they do not react. What happens in science is if you make a hard set rule like that, some smart ass is going to make it their life's mission to make them react. And we have since made all of those react, just not in conditions we're going to see in our lab. All right. So these noble gases, we had to change the name. Couldn't call them inert gases if they'll react. All right. So noble gases, halogens. Over on the left, alkaline metals, alkaline earth metals. Now that means those 4 have 4 acceptable names. All right. So when I'm looking over here at chlorine, chlorine is in the halogens. It's in group 17. It's in group 7A. It's also in the fluorine family. Those are the acceptable names for that family, that up and down. Okay. All right. So the other big dividing thing that we worry about, and that's what most of this coloration that we see going on here, is really trying to help us to figure out what things are metals and non-metals. And metalloids is what our book calls it, but I call them semi-metals. So it's actually quite easy. You find your staircase. And so here's my staircase. Down, over, down, over, down, over, down. And then we're not sure. This one shows it going down and over. Yeah, we don't have any, evidence to back that up down there. So here we go. We've got non-metals over to the right, and the metals to the left. Easy way. These are the alkaline metals, alkaline earth metals. So going towards them, there's the metals. You can also see over here I've got iron and copper and silver and gold, things that we think of as metals. Lead's down here. So those are the metals. Easy enough. Now, the things that we associate with metals, so they have certain properties. We have stuff like luster, and that's shininess, whether something is ductile. Got myself in trouble. Now I got to try and spell malleable. That doesn't look right at all. Let's see. What else are we? They're solids. They are conductors. They conduct heat and electricity. All these kind of things.